Hello, welcome to class. This is Smart IQs, where we specialize in nurturing smart IQs. Don't forget to join our community of smart IQs. Hit the like buttons, subscribe. Okay? More videos will be released. At Smart IQs, remember our classes are designed for personalized studies. Okay, our classes are also designed for exam prep. We want to prepare for exams, and also our classes are designed for homeschooling. It means you can be wherever you are. So as you follow our classes, you can be homeschooled. Okay. So let's get down to class, to what we have today. So week 2 of chemistry, don't forget, the periodic table. We'll talk about periodic table part 2 today. Okay? And by the end of the lesson, you should be able to state the periodic law, okay? And you should be able to explain how elements are arranged in the periodic table. You should also be able to state the properties and trend in the periodic table. Okay? So remember last time we talked about introduction to periodic table in part 1. In case you are yet to watch the part 1, do yourself a favor by doing that, okay? Because that is a building block for part 2. We talked about our periodic table as being tabular arrangement of chemical elements based on their certain properties such as atomic numbers, properties such as electron configuration, properties such as their chemical properties. Okay, and we talked about the historical background of the periodic table. We said that Dmitry Mendeleev was a pioneer of the periodic table that has since metamorphosed to the modern one we have now. Okay, in 1869. Then we talked about of what importance is the periodic table. We said for organization tools, okay? You have to arrange and organize elements, certain elements, based on their chemical properties. Are we together? Then we also talk about predictive power. So it helps us to be able to predict, okay, the properties of unknown elements. Are we together? Then we also talked about as a basic cornerstone to chemistry. It helps us to understand the basic fundamentals, okay, of matters. Then, so let's get straight to today. So you should be able to state the periodic law at the end of this class, and like I said, okay. So to every concept in science, okay, we try to make a law available. You get based on certain experiments. So periodic table is not exceptional. Okay, so the law states that the repeating chemical and physical properties of elements change periodically with the element atomic number. Okay, so as the atomic number changes, okay, as the atomic number changes periodically, okay, then their chemical and physical properties in a repetitive manner will also change. Okay, so that means repeating chemical and physical properties is at the mercy of periodic change in the atomic number. Are we together? Good. Then how are elements arranged? How are they arranged in the periodic table? Of course, I've talked about group before, so let's have it now. You can see vertically elements are arranged into groups. Okay, so this one is group 2 as we have it there now. Okay, so as I told us last time that elements in columns are known as group. Okay, good. Then also elements are arranged horizontally, and that will be in period. Okay, that will be what? In period. So as you can see, these are the arrangement of elements in the periodic table. Okay, good. Then groups and periods. To further buttress groups and periods. Groups, elements in the same column will share definitely similar properties, and this is due to their numbers of valence electrons. Okay, elements in group 1, for example, they are metals. Okay, they are alkali metals, and they are very reactive. Okay, they are electropositive. Now, they share these properties because they all have 1 electrons in their outermost shell. Okay, good. So period, of course, elements in the same rows have increasing atomic numbers. Okay, they have the increasing atomic numbers. Also, elements in the same period, we have the same numbers of shell. Okay, they have the same number of shells. Good. So they share elements in the same groups or periods have a similar or common characteristics. Okay, so and also the periodic table. Okay, we've been able to see that how elements are classified. So of course, we know in our previous knowledge that elements are classified into metals, non-metals, or metalloid, and this is based on their chemical on their properties. Okay, good. So so let's talk about trend now. Periodic trend. Okay, and we're going to consider these pictures before us. Okay, good. Let's pick our pen so that we can be able to do justice to that. So good. Now, certain trends, I'm going to be explaining this trend based on certain properties. Okay, like the atomic size, electropositive. Okay, how electronegative is of those elements. Okay, the ionization energy. Okay, are we together? Good. Now, let's start with atomic size. Okay, now atomic size of an element in the periodic table will decrease. Okay, we increase down the group. Okay, and then we decrease across the period. Are we together? So that means as I move down the group in the periodic table, atomic sizes what? Increase. Atomic size increases. Are we together? And as I also move from left to right in the periodic table, the atomic size decreases. Are we together? Good. Then let's talk about electropositivity. Okay, how electropositive group in the periodic table. Now, as we also move down to the periodic table, as we move down, okay, as we move down across the, down the period, the group, please, okay, as we move down the group, the electropositive of the element increase. Okay, it increases. So that's why you can see that sodium, okay, is more electropositive than lithium, and then potassium is more electropositive. Are we together? So electropositivity increase down the group. Okay, whereas electropositivity, of course, decrease across the period. Of course, it's going to decrease because as you move from left to right, you are moving away from metal to non-metal. Are we together? So there's going to be a decrease in electropositivity. Are we together? Now let's talk about electronegativity. Okay, electronegativity will increase. Okay, across the period. So as we move away from the left-hand side of this periodic table to the right-hand side, electronegativity increases. Okay, because we are moving from metal to non-metal, and we know that metals we always accept electrons. Okay, to accept electron. Okay, electronegativity, electron affinity. These two characteristic is important, especially to non-metals. So electronegativity, electron affinity will always increase across the period. That means as we move from the left to the right, the electronegativity and electron affinity will increase. Okay, that's being said, it means that both properties, their trend as far as down the group is concerned they will decrease. Okay, if electron affinity and electronegativity increases across the period, they also decreases down the group. Okay, also electron ionization energy increases across the period. Okay, please take note, and decreases down the group. So it increases across the period and decreases down, okay, the group. Okay, are we together? Good. So to have it more, look at it here now. Okay, now you can see them now, the groups. So atomic radius increases, okay, and that is from top to bottom down the group, and also it's going to decrease from left to right. That is across the period. So ionization energy, stated it already, decrease down the group and increase from left to right. Okay, good. Electron affinity, decrease down the group and increase from left to right. That's across the period. Then electronegativity, decrease down the group and increase from left to right. Electropositivity, we increase down the group and decrease from left to right. Metallic nature, okay, also is going to increase down the group and decrease across the period. And the non-metallic nature decrease down the group and increase across the period. Okay, so I'm sure you've understood this trend now and clear like as crystals. Okay, good. So the class has been awesome, and I believe you've been following the class. Is that not? Okay, so let's talk about properties of this of certain elements, especially considering their groups. Are we together? So let's talk about of course we know that the periodic table is divided into several groups, and this is based on their their properties. Okay, good. So let's have it now clear. So group 1, remember I told us that we have group 1 to 18, that is in the numeric labeling. But if we talk about Roman numeral, we have group 1 to group 8. Okay, good. So let's talk about group 1 quickly. Group 1 elements, as you can see, group 1 elements, they are called alkali metals. Okay, are we together? So they are metallics and they are alkali metals as they are being called. They are very reactive. Okay, they're very reactive. They are soft and they are silver colored. Okay, metals. Okay, and they shine with low density. Are we together? These are the properties of group 1 elements. Okay, good. So we have a lithium, you can see that, and the sodium. Sodium, you can easily cut sodium. Okay, are we together? Good, because they are soft. Okay, good. So let's move straight to the alkali earth metals, please. And these are found in group 2 of the periodic table. So alkaline earth metals. Okay, they are found in group 2, and these elements, they are silvery white metals. Okay, they are fairly reactive when compared to group 1. Of course, I told us that group 1 is very reactive. Are we together? Good. And many of these elements found in group 2, many of them are found in rocks, okay, in the earth crust. Are we together? Good. We have the magnesium, okay. These are group 2 elements, as you can have it now. Good. So we have them. They are also metals, don't forget, but not as very reactive as the alkali earth metals. So magnesium, and this is magnesium oxide. Okay, good. Let's move straight as we talk about the transition metals. Okay, the transition metals, they are found between group 2A and group 3A. Okay, they are very important metals. Okay, They are very important elements. Okay, of course they are not just elements; they are metals. Okay, so most are good conductors of electricity. Okay, most of them are good conductors of electricity. Most of them they are malleable. Okay, that means they can be hammered. Okay, into wires, into thin sheets or plates. Are we together? And the ions are colored. Okay, they have colored ions. Are we together? And then they have variable oxidation number. Okay, they have variable oxidation number. So take note of that. Are we together? Good. Okay, so these are metals found in that particular category of the periodic table. Okay, so you can see how important they are. I'm sure you can recognize all this. Okay, wrench, wheel, okay, planes, and what have you, coins, and the likes. So these are very important. You can see in our day-to-day production line, we make use of these metals. Okay, good. So let's move straight to the metalloid. Okay, the metalloid, as you can see, the arrow, the lies on either side of the staircase. Okay, we have the aluminium, the germanium, and what have you. Okay, the silicon and the rest, the indium. Okay, good. So they share properties with both metals and non-metals. Okay, and that's why we call them metalloids. Okay, and silicon and germanium, okay, are very important semiconductors. Okay, in the semiconductors technology, we know what silicon is and we know what germanium is. Okay, good. Let's move straight as we have a various application of semiconductors. Okay, so that you know how important the metalloids are. Also, you can see it. So semiconductor technology. Okay, various chips in our monitors and CPUs, in our laptops, okay, and our disk, and the rest, what have you. This makes use of semiconductors. Okay, and we've told you earlier that silicon and germanium play a key role in semiconductors technology, and these are metalloids. Okay, they are found on either side of the periodic table. Are we together? Good. So the non-metals, okay, from group 3 to group 6, we find the non-metals. Okay, where you have your boron, your carbon, your nitrogen, your oxygens. These are non-metals. Okay, even hydrogen is a non-metal. Now, hydrogen is placed in group 1. Okay, hydrogen is placed in group 1, not because it's a metal, okay, but because of for convenience sake. Okay, it's placed in group 1. Remember that you just have only one electron. Okay, so for convenience sake, we place it in group 1. But hydrogen is a non-metal. It has a non-metallic characteristic. Are we together? So, and one of the characteristics of non-metals, they are brittle. Okay, they can easily be broken. Are we together? And they do not conduct electricity. Non-metals do not conduct electricity. They do not allow the passage of electricity. Are we together? Good. Okay, so I'm sure you have also heard about the halogens. Okay, and that is group 7. The group 7 elements, starting from fluorine, chlorine, bromine, iodine, and astatine, they are all called the halogens. Okay, they belong to they are the halogens family. Are we together? And most of them are poisonous. Okay, most of them are poisonous, and they are fairly reactive, especially with alkali metals, where we have the sodium chloride reacting with, sodium, okay, reacting with chlorine. Are we together? Okay, sodium reacting with, of course, chlorine. Then we will get sodium chloride. Okay, we get what? Sodium chloride. Good. Sodium chloride. Are we together? Good. They are also poor conductors of electricity, okay? And they are never in pure form as far as nature is concerned. They are never in pure form in nature, okay? So, among them, fluorine is the most electronegative element. Are we together? Good. So, chlorine, you can see that. That is a picture of chlorine. Are we together? Good. And before I move on, don't forget most of them they exist in diatomic molecule. Chlorine exists in diatomic molecule. Okay. Are we together? Good. So we have the noble gas, the noble gases, and that is the last group 8. Okay. The noble gases, they are very stable. Are we together? And because of their stability, they are unreactive. They are unreactive in nature. Okay, and most of them are gases at room temperature. They are also non-metals, of course, but we place helium there. You can see helium. Initially, any member of the group 8 are supposed to be having 8 electrons in their what? In the outermost shell. But helium has 2 electrons in the outermost shell. So why is helium placed in group 8? Because helium has met with the criteria of stability. You know, for an element to be stable, it must have attained what we call duplet and octet state. Okay, and so helium has attained what is duplet. Okay, the duplet state. The duplet state. Okay, did what? The duplet state. So that means helium is stable. Are we together? Then others, neon, kryptons, and xenon, and the rest, all of them has what? 8 electrons in the outermost shell. And because they have 8 electrons in the outermost shell, you never find us writing any equations, especially chemical equations involving this element, because they are chemically stable. Are we together? So they neither give electrons nor receive electrons. Are we together? So let's move straight. Of course, I've talked about their numbers of electrons in the outermost shell, and that is 8. Okay, and they are colorless, they are odorless, and they are also gases at room temperature. Are we together? Good. In fact, every element looks up to the group 8. You know, they look at group 8 and say, we want to be like you when we grow up. Are we together? Good. And in the process of trying to become stable, that is when reactions occur. Okay? Because when you want to become stable, 2 things are going to be involved. Either you give electrons or you receive electrons. Are we together? And when you give electrons, that means you lose electron and you become ionized completely. Are we together? When you receive electron, that means you gain electron, so you become ionized completely. And that means those one that gains, they are non-metals. Those one that lose, they are metals. Are we together? You can see how this thing works. Good. So neon is powerful examples of the noble gases. Okay, are we together? Good. So we have certain chemical groups, and there are 4 we talk about: the alkaline metals, the group 1, and the alkaline earth metals, the group 2, the halogens, the group 7, and the noble gas, the group 8. Okay, as we've seen them. So group 1, group 2, group 7, and group 8. These are called the chemical groups. Are we together? Very good. So you have enjoyed the class today, and you are very much welcome to our channel once again. Don't forget to hit the like button, subscribe, as we are on the course to developing and nurturing smart IQs. Okay? I'll see you in the next class.